So thanks very much for having me today. Again, my name is Lexi Davis, and I am the Great Lakes Water Resources Scientist with the New York State Department of Environmental Conservation, Great Lakes Program, and Finger Lakes Watershed Hub. And thanks again for having me today. I'm going to be giving an overview of the DEC's monitoring, planning, and implementation efforts in the Finger Lakes watersheds. So I will cover topics ranging from the Division of Water, or what the Division of Water is, to progress tracking. So I hope there's something of interest to everyone in the presentation here today. Let's see if I can. Okay, here we go. So just a little bit of an introduction for myself. I grew up in Pennsylvania and moved to New York for my education, and I studied riparian ecology in the Finger Lakes region for my master's thesis and fell in love with the area. So I decided to stay. I worked as a natural resources specialist for the Hugo Lake, and since 2022, and joined the New York State Department of Environmental Conservation in 2023 in my current role, where I focus on watershed and water quality within the Great Lakes Basin for the Great Lakes Program and the Finger Lakes Watershed Hub, which I'll give a little bit of a background on next. So the Great Lakes Program is what we call an executive program, so it is not directly under the purview of the Division of Water, but the program does work closely with DOW, or the Division of Water. So the program covers the New York Great Lakes Basin, so that's the green on the map here, and includes 4 subbasins. So the Lake Erie subbasin, the Southwest Lake Ontario subbasin, the Southeast Lake Ontario subbasin, which includes the Finger Lakes, and the Northeast Lake Ontario and St. Lawrence River subbasin up in the north. And what drives this program is working with partners and stakeholders in the implementation of the Great Lakes Action Agenda, which came out with an update in 2023. So I would encourage all of you to take a look at that if you're in the Great Lakes Basin, or if you are outside the Great Lakes Basin as well. And then the Finger Lakes Watershed Hub is housed within the Division of Water. So it's not an executive program, and it is in the Bureau of Water Resources Management, or BWRM, but works across the division with various programs and bureaus, and was founded in 2017 in response to an increase in algal blooms affecting the Finger Lakes in 2016. So again, the hub was formed in 2017 and tasked specifically with conserving, preserving, and restoring the environmental quality of the Finger Lakes and their watersheds. So in this presentation, I will discuss various topics, with the first being more about the Division of Water and how it drives what we do, what monitoring we are doing, and how that informs things like planning and management, grant funding and implementation, and the tracking of progress. So for background on the Division of Water, I will outline where this division falls within the broader DEC. So this flowchart shows the overall Department of Environmental Conservation and how all of those divisions and pieces go together. And the point of this chart isn't to be able to read and see all of the names of these, but I just wanted to show that the Division of Water, which is highlighted in yellow, is just a small piece of the broader DEC and the work that is being done for the environment. So specifically within the Division of Water, this houses all of the programs related to water resources, watershed programs, and basin commissions. So something that drives the Division of Water is what is called the water wheel. So no need to memorize this, of course, but I would like to point out that these steps or objectives of monitoring, assessment, planning and management, implementation and permitting, and compliance and enforcement all feed into each other. So the science behind monitoring drives the assessments, assessments drive the planning, so on and so forth. And watershed plans, which I'll talk about in some following slides, are what really show the use of this water wheel, which we in the Division of Water and other stakeholder partners use to protect and restore water bodies from various stressors and pollutants. So starting off with the first part of the water wheel, that is usually the most fun to participate in, is the monitoring aspect. And I have two parts to this section within the monitoring section. So the first is water quality. So DEC has many different monitoring programs, and all the data collected with these programs is accessible through the Division of Water Water Quality Portal, which is the link shown here in here. And this is, if you go to the Water Quality Portal, this is what it looks like online. So the red dots indicate where stream sampling data has been collected, and the blue dots indicate where lake sampling data has been collected. So there's quite a lot of data here. We pride ourselves in branching out across the whole state to collect data and ensure safe drinking water. So this is updated yearly, so you can find all the data related to any sampling done in this portal, and you can also download any of the data that is in there as well. So some of the programs that influence this data are programs like the CSLAP program, or the Citizen Statewide Lake Assessment Program, and the WAVE program, or Water Assessments by Volunteer Evaluators, which are citizen science programs that utilize volunteers to collect valuable data in their areas that we can use for later analyses. So for DEC, we have example the Lakes Program, or LCI, the Lake Classification and Inventory Program, which has more than 7,600 water bodies that are evaluated through a 5-year rotating basin that measure parameters like nutrients, so phosphorus and nitrogen, for example, chlorophyll A, water clarity, metals, and many others. And a streams program, which was initiated in 1972 and focuses on the screening network and special survey monitoring for strategies. Approximately 75 rivers and stream locations across the state, with some additional locations being sampled periodically each year for similar nutrients as the lakes, so phosphorus and nitrogen, as well as dissolved oxygen, pH, turbidity, and more. The NIHAPS program, or New York Harmful Algal Blooms, is a citizen reporting tool that allows people to submit suspicious bloom reports across the state. There are also various local monitoring programs conducted by nonprofit organizations, private organizations, and academic researchers as well. For the Finger Lakes Hub specifically, we participated in a special study this past summer as part of the LCI program, which are the pictures on the bottom here. So we sampled each of the Finger Lakes once per month for 6 months over the summer, and we'll collect more samples next year. And this will result in a report with the data being available once completed. This summer, we were fortunate enough to have interns through SUNY ESF, which helped us greatly throughout the sampling season. So Molly, our intern, and I on the left, and Bronte and Oliver on the right. And if you haven't noticed yet by the couple of photos of me out in the field, I always seem to be on the crew that is sampling in the rain. So hopefully I have some better luck next year. We also have a 2017 through 2023 water quality report, or the 7-year water quality report, as we are calling it, that will be published soon and is in internal review now. This report analyzes data collected through the CSLAP program and other programs such as the winter limnology effort that was completed by Hub staff over the course of a few years. So today I will give a little bit of a sneak peek into some of the results that will be shown in this report. So I'll start off with everyone's favorite nutrient, phosphorus, which I'm sure most, if not all of you, have heard of before. So just for some background, phosphorus is an important nutrient for algal growth and the development of harmful algal blooms, or HABs, and is usually the limiting nutrient in the Finger Lakes, which means that It is what is in shortest supply and therefore gets used up first, which restricts the growth and productivity of organisms in an ecosystem. So for some preliminary results, here is a figure showing the average total phosphorus concentrations for the Finger Lakes for our 2017 through 2023 period. So there are a few things to look at here. So on the y-axis is the concentration in milligrams per liter. And the value of 0.02 is circled and is labeled with GB for guidance value, which is the value indicated by a eutrophic or high nutrient trophic status, which is what honeyoy is classified as. Mesotrophic is in the middle and is between 0.01 and 0.02, which is where most of the Finger Lakes hang out. So Canisius, Seneca, Cayuga, Owasco, and Otisco. And oligotrophic is low nutrient, which is between 0 and 0.01, which includes Canadice, Canandaigua, Cayuga, and Skinny Atlas. And on the very right is an average of all of the Finger Lakes and the non-Finger Lakes, lakes within New York, so you can see how the individual lakes compare to the others. So when we look at the total phosphorus concentrations over time through historical and current data sets, with the lighter color being the oldest to the darker color being the most recent, we can see that there is an upward trend in Honeoye and Otisco lakes over the last 50 years, but most of the lakes are either staying status quo or decreasing trends for total phosphorus. Okay, moving on to chlorophyll A, which is a surrogate of our algal growth. So this figure shows the average chlorophyll A concentrations of the Finger Lakes for the sampling period of, again, 2017 through 2023. Again, we have concentration on the y-axis, but this time in micrograms per liter, and the lake on the x-axis with the guidance values still shown with the same 3 trophic classes. So eutrophic is the highest concentrations of chlorophyll A, and again includes honeyoy, and almost Otisco over there. Mesotrophic includes most of the Finger Lakes with Canisius, Hemlock, Canadice, Canandaigua, Cayuga, Seneca, Owasco. And oligotrophic includes the lonely Skinny Atlas on this one. On the right, again, we have the average values for all of the Finger Lakes and non-Finger lakes in New York, so you can see how each of the Finger Lakes compares to those averages. And when we look again at the chlorophyll A concentrations over time through historical and current data sets, with the lighter color being the oldest to the darker color being the most recent, we can see it again that there's upward trend in Honeoye and Otisco lakes over the last 50 years. There are some increases in other lakes, but not as significant as Honeoye or Otisco, with some decreasing as well. There are also some questionable values, which are indicated by the question marks on the bars as well, but we can't very well go back to 1973 to validate. So just wanted to point that out there. And looking at both of these, it is generally known that total phosphorus is related to chlorophyll A and Secchi disk, which is a measure of water clarity. So what this slide is showing is on top a regression with chlorophyll A on the y-axis and total phosphorus on the x-axis. All of the values are plotted and a line of best fit is drawn to measure the strength of the relationship of the independent and dependent values based on the slope of the line. So with the R-squared value of 0.97, this indicates a very strong relationship with a value of 1 being a perfect relationship. And on the bottom, similar but a little bit different, a correlation with Secchi disk depth Again, so the measure of water clarity. On the y-axis, we have the Secchi disk depth, and on the x-axis, again, total phosphorus. So all of the values are plotted and a line of best fit is drawn to determine the association or co-relationship between the two variables. And with the R-squared value of 0.81, this also indicates a strong correlation. So to summarize, total phosphorus is still highly related to chlorophyll A and highly correlated with clarity, which are often the focus of clean water plans, which we will talk about in a little bit. And I also want to note that chlorophyll A is not directly related to HABs, but it is related, which is a great segue into the next monitoring section, which I know you are all dying to hear about, which is harmful algal blooms. So the DEC has a long-term holistic approach to HABs through monitoring and watershed management, including work like we are doing with the LCI study, clean water planning, and pollutant reduction strategies for long-term controllable causes, as well as funding projects to reduce occurrence of harmful algal blooms through sources like WQIP or water quality improvement projects and NPG, which are non-agricultural, non-point source planning grants. To date, over $428 million has been awarded through these avenues to nutrient reduction projects. We are also focusing on research into harmful algal blooms and their causes, with a focus on prevention, mitigation, monitoring, and modeling to understand causes. There is a New York State DEC HABs research guide to guide these research objectives. And to date, over $14 million has been awarded to complete research relating to this. We are also looking into in-water body mitigation through development, implementation, and evaluation to help control bloom size and formation. So there is a significant interagency collaboration when it comes to HABs, with partnerships among the DEC, the Office of Parks, Recreation, and Historical Preservation, and the Department of Health. DEC coordinates the reporting and hosts the NIHABs interface, which I talked about a little bit before. The Parks Department regulates swimming areas and have a protective response protocol based on visual observations of blooms. And the Department of Health oversees health concerns and drinking water treatment. So the NIHABs reporting system was established in 2019, and from the chart you can see that the number of confirmed reports has definitely increased over the years. It is no secret that HABs have increased across the world and across the United States in recent decades, which I can't go without talking about observer bias, which means that the more you look, the more you're going to find. So as HABs have become a major topic of for everyone, really, there has been an increase in the number of eyes looking, and therefore an increase in reporting. So not to say that HABs are not increasing, but just pointing out that the system isn't perfect. So HABs have been increasingly being reported in low and moderate nutrient lakes, like the Finger Lakes, for example. So in response, in 2018, New York State established the HABs action plans, which I will speak on a little bit more later. But these were written for 12 lakes in New York, with 5 of those being in the Finger Lakes. And we have been implementing these since 2018, and many authors, like those listed on the screen, have contributed to these. So these outline that there are 4 different factors that really influence HABs, which there are more, but these are just the major ones. So first is the presence of dry-sinded mussels, or zebra and coaga mussels. So all of the Finger Lakes, and I think honestly probably most lakes, have. However, toxin production is not always linked to nutrients in dry-sinded impact systems. Lake fetch length which is the maximum distance that wind can blow across a lake without obstruction. Lake orientation and phosphorus levels are also influential factors. And I want to stress that nutrient, water quality, and HABs are separate. The two are not always neatly linked, but phosphorus is now the only factor we have some control over in these situations. So the uncontrollable factors are the mussels, the lake fetch, and lake orientation. So there's also the question of how hot, calm fall conditions influence this as well. So this year was the perfect example of a hot, no wind spell in early fall where there were significant blooms, like in Seneca Lake shown on the photos in the right. So for the Finger Lakes specifically, harmful algal blooms were first confirmed in all the Finger Lakes back in 2017. And as you can see in this chart, since 2022, this has been the case. So the orange color notes the Finger Lakes that have an average summer total phosphorus concentration of less than 10 micrograms per liter. So this is considered fairly low. So the point that I want to make here is that the presence of HABs is not always tied to the amount of nutrients or even the land use of the watershed for that matter. So the Hemlock and Canadice watersheds are the perfect example of that, with the summer average total phosphorus concentrations being less than 10 micrograms per liter and 73% of their watersheds being forested. So a major accomplishment of the DEC in terms of HABs efforts is the work of the Advanced Monitoring Pilot Project, which resulted in 2 websites, which are now live, about 11 peer-reviewed reports, 6 data releases providing all the data collected from the pilot, including in-water body sensor data, other environmental conditions, lab biological and nutrient data, algae and cyanobacteria counts, and identification, and data on stream health, habitat, and hydrology, 1 master's thesis, and 7 quality assurance plans and other valuable documents. Unfortunately, I can't present today on a perfect solution for HABs, but we are doing a lot of work in terms of in-water body mitigation research, which include approaches in combination, so the use of chemical algicides and physical controls like water column mixing. But the scale of these treatments is a limiting factor, as this is relevant for a small cove, for example, but not for a lake the size of a Finger Lake. Ultrasonic devices were tested in 3 different lakes. Ultrasonic zooplankton and phytoplankton studies were completed. Ultrasonic fish responses through mesocosm and in situ or on-site studies were completed. In-lake feasibility studies of alum application was completed in Honeyway Lake. There was an Agawam algal skimmer and hydrogen peroxide oxidation treatment experiment, and electrochemical oxidation and hydrodynamic cavitation. So all of these science and monitoring efforts are, again, what drives watershed management, which is what we will cover in the next section. So let's begin with what are clean water plans. So these are data-driven plans that are set in an effort to restore and protect water quality. And the EPA and the DEC acknowledge that there is not a one-size-fits-all approach to restoring and protecting water resources. So these plans can look different for each watershed they are intended for. I'll go over the different types of clean water plans on the next slide. But to summarize, these plans document watershed characteristics, pollutant sources and loads, allowable pollutant levels to meet best uses, and they have a strong implementation plan with adaptive management, which recommends actions that will improve and protect water quality. And the image on the right shows the geographic region that is covered under a clean water plan, which is a decent portion of New York State. So the Clean Water Plan most people have probably heard of are TMDLs, or total maximum daily loads. But the DEC has been implementing tools beyond TMDLs to include other clean water plans, such as the others listed on the slide here. So it can be a bit confusing sometimes to determine which clean water plans are used for certain circumstances. So there is this handy flowchart that helps with that decision. So the first question is if a water body is impaired, meaning if it is deemed by EPA to be impaired. If the answer is yes, this calls for a TMDL or advanced restoration plan, depending on if there is a clear action that can be implemented. TMDLs are used when this action is clear. If the water body is not impaired, the next question is who is writing the plan? So if stakeholders are driving the writing of the plan, a 9-element plan is used for watershed pollutant reduction, or a drinking water source protection plan, or DWSP2 plan, is used for local comprehensive water supplies protection. If the DEC is writing the plan, an action agenda is used to outline whole watershed protection and restoration. And protection TMDLs are used to protect a water body from a specific pollutant. And harmful algal bloom action plans are used to address economically important watersheds. And the asterisks indicate plans that are rarely used. And I want to mention that there are other types of plans, but they are not typically recognized by the Division of Water. So in the Finger Lakes specifically, this chart outlines the plans that have been completed. So all 11 of the Finger Lakes have completed a Division of Water recognized plan of some kind, with some being included in 9-element plans, TMDLs, DWSP2s, and HABs action plans. I also want to note that those in red have been completed since 2018. So there has been significant progress completed within the Finger Lakes over the last several years in terms of clean water planning. You might be thinking, what are the benefits of doing these plans? So there are several short-term benefits, which include an update or inventory of the watershed, the establishment of watershed monitoring programs. This process begins the quantification of nutrient and sediment impacts and locates specific areas of concern and focuses attention to those areas. And the point I want to drive home is that these are science-based decisions to help focus best management practices and resources to critical areas. And the long-term benefits include an understanding of the watershed and its issues, build partnerships for extended and effective management. It acts as a common plan for current and future management. The models can be used to focus resources. The completion of any of these increases eligibility for funding and state funding. So I want to point out that just having one of these is the golden ticket for unlocking the increase in eligibility. So you don't get a better chance by having completed more of these plans. Just one is needed, which is the perfect lead-in for the next section of the presentation, which covers grant funding. So if you weren't already aware, the DEC has developed a fantastic tool called the Funding Finder. So this tool allows you to look for funding using a spreadsheet that allows you to filter by parameters to find funding relevant to the project you would like funded. I highly recommend checking it out. It's you can use it when searching for potential funding sources for projects. So a funding source that many of you have probably heard of, and one that I mentioned prior in this presentation, is the Non-Agricultural Non-Point Source Planning and MS4 Mapping Grants, or NPG. Eligible applicants for this grant are municipalities and soil and water conservation districts. The maximum awards are up between or up to $50,000 for planning reports and up to $75,000 for comprehensive stream corridor studies. And eligible practices include projects like green infrastructure practices, stream bank or shoreline stabilization, and water control for nutrients, bathing beach restoration, stream culvert repair and replacement. And in 2023, a few were added, which are floodplain creation, restoration, and reconnection, berm removal, wetland creation or restoration, coastal storm and erosion risk management, and dam safety, and many others. All reports and findings funded by this grant are submitted to DEC and are completed within 2 years. For the municipal separate storm sewer system mapping grants, or MS4, these eligible applicants are municipalities regulated by the MS4 general permit and soil and water conservation districts on behalf of regulated MS4 operators. So if applying as a municipal collaborative, up to $60,000 per municipality is available, with up to $400,000 per collaborative application. If applying alone, the max award is $75,000. $75,000. Sorry. The final result of this grant is a comprehensive map of the stormwater system and final summary report. So here are the listed planning categories eligible for funding. The program overview provides a description of the grant categories, their specific requirements, and the types of reports that can be produced, and the level of planning that can be funded. So I mentioned some of these on the prior slide. So I'll just leave this up here for a minute for you to look before I shift to the next. Again, all the reports and findings funded by this grant are submitted to DEC and have a max term of 2 years to complete their reports. Another funding source you have probably heard of is the Water Quality Improvement Project Program, or WQIP. The funding source for this grant is the Clean Water Infrastructure Act and Environmental Protection Fund. Maximum award amounts vary by project type, but range from $100,000 to $15 million. Match is required and is based on the award amount, not the total project cost, with a 25% match of the requested funds or awards. The eligible applicants include municipalities, soil and water conservation districts, non-for-profits, so those that include land acquisition for source water protection, aquatic connectivity, and marine district habitat restoration. And both NPG and WQIP provide funds to complete critical implementation efforts, which I will talk on and which I will speak about in this next section. So the implementation and capacity needs are common across all the Finger Lakes. And as I said earlier, the clean water plans and other Finger Lakes plans echo this need. So New York State is progressing work to build capacity and increase implementation across the Finger Lakes, including the establishment of the Eastern Finger Lakes Coalition, which includes the Eastern Finger Lakes from Canandaigua through Otisco, and the soil and water conservation districts within their watersheds. Similarly, there is advancing work with the Genesee River Watershed Coalition, which covers the 4 Western Finger Lakes and includes updating a watershed implementation plan with stakeholder input, establishing a new MOU with the Genesee Coalition, advancing a 9-element plan data gap analysis, and continued implementation support through the Great Lakes Action Agenda. The Finger Lakes Hub and the Great Lakes staff are working with districts, counties, and FLOPA, which is the Finger Lakes Lake Ontario Watershed Protection Alliance, to increase the acquisition of federal dollars in the Finger Lakes. New York State is working to secure supplemental funding to build upon existing programs like FLOPA. And the FLOPA line for funding has increased over the years. And DEC and the Department of Agriculture and Markets, or Ag and Markets, are working closely with the soil and water conservation districts to build capacity to accelerate best management practice implementation for both agricultural and developed lands or non-farm in the Eastern Finger Lakes. Implementation will be guided by the completed clean water plans previously mentioned that cover the Finger Lakes region, so TMDLs, HABs action plans, 9-element plans, and source water protection plans, and the Soil and Water Conservation District strategic planning documents. And all this work will continue the investment in protection of the Finger Lakes and help to tackle new challenges such as climate and flooding resiliency. Some other implementation items within the Great Lakes and Finger Lakes region are the cover crop program, which in round one successfully planted over 4,500 acres of cover crops to help reduce nutrient runoff and protect soil health, with round two underway. The first round of the Finger Lakes grant program was awarded this past year, with the funding being used to implement projects to restore and protect water quality, conduct monitoring and research projects, planning and implementation projects, and education and outreach within the Finger Lakes region. And these projects are currently underway. The Great Lakes program also has various programs such as their small grants program and sediment nutrient reduction programs, Sustain Our Great Lakes program, which all goes into supporting the Great Lakes Action Agenda. And the Finger Lakes is in development of an action agenda for the Finger Lakes as well, which closely aligns with the Great Lakes Action Agenda, while also considers the unique challenges and needs of the Finger Lakes and their watersheds. And we anticipate this being public noticed in early 2025. So some examples of implementation projects that occurred with some of these funds were conducted in the Cayuga watershed through New York State, Soil and Water Conservation Districts, and other entities. There were 40 implementation projects awarded in the Cayuga Lake watershed between 2013 and 2022, with more than $14 million and 39,000 pounds of phosphorus per year reduced through projects such as nutrient management and cover crops, stream bank stabilization and hydroseeding, and land acquisition, riparian buffer plantings, and exclusion, and septic pump outs. It is critical that we not only participate in these implementation efforts, but we also track them and their metrics to measure success and investment over time, which is what we will talk about in this project progress tracking section. Like I said, action agendas and clean water plans require progress tracking of some kind in order to measure success. The DEC is currently working on a project tracking system that does just that, so we can also locate gaps and provide visualization of progress. The tool is designed to track watershed progress by leveraging existing databases that are outlined here. So for federal sources, those are tracked with the Great Lakes Commission Investment Tracker, which includes Great Lakes Restoration Initiative, or GLRI funds, Infrastructure Investment and Jobs Act funds, and Inflation Reduction Act funds. State sources include the non-point source database, which includes funding through the Department of Agriculture and Markets with Climate Resilient Farming, or CRF, agriculture non-point source abatement and control programs, or NPS, and the WQIP database, which includes funding through DEC and includes the WQIP funded projects. The tracker synthesizes and summarizes all of the funding and project information about funded projects at the HUC 12 or watershed scale. as this removes point locations for privacy concerns. The output is what this draft map looks like here, with the federal funds indicated in blue, DEC funds in green, and Ag and Markets funds in orange. 4 layers are currently developed, which include project information, summaries, load reductions, and watershed summaries. So for the project information, this layer shows most of the variables provided through the application. So when a HUC 12 is selected, a pop-up is shown with this project information, and you can click through the various projects that occurred within the HUC. So for example, this is a HUC within the Seneca watershed, and we can see the project information related to all the projects that were conducted within this HUC 12. So there were 2 of them, so you're able to click through those. And for the summary information, this layer summarizes the total funds awarded and the number of projects that occurred within the HUC. So when a HUC 12 is selected, a pop-up is shown with these summaries for the specific HUC. For the load reduction information, this layer shows the awarded summary of total nitrogen, total phosphorus, and total suspended solids load reductions in pounds per year. These are calculated at the HUC 12 scale and can be summarized at the watershed level. When a HUC 12 is selected, a pop-up shows these calculations as well as the number of projects that occurred to contribute to those load reduction amounts. So this is the same HUC 12 that I selected in the previous slide. So you can see the load reductions listed here and the number of projects that contributed to these load reductions. The watershed summary layer builds on the HUC 12 level summaries and clips the data to a watershed of interest. So these summaries include the total funds and total number of projects that occurred within the watershed. So when a watershed is selected, so in this case, Seneca Lake, the total number of funds and projects is shown. And since this data is mapped, we are able to complete this summary for any watershed, region, county, or shapefile of interest. So this pop-up shows the total number of funds that were spent within the Seneca watershed and the total number of projects that occurred in the Seneca watershed as well. Therefore, we are able to complete progress and load reduction lists like this example for the Cayuga Lake watershed. We hope to make this publicly available so stakeholders and interested people are able to see how and where funds are spent. So thanks for hanging in there for this presentation. Again, my name is Lexi Davis, and you can feel free to contact me through the means listed on the screen for any questions, and I'm happy to answer, well, try to answer any questions that you may have.